Greetings and welcome back to this topic on selection and decision structures inside of UiPath Studio. We are going to continue with our normal sequence or cadence here of starting a brand new project via a blank process. So on the top right corner, go ahead and click New Project by Process. We will give this one a name of Selection Structures. Go ahead and ensure that your paths are being saved in a folder of your choice. Hopefully, if you're following along with all the videos as part of this tutorial, you're keeping them kind of grouped in the same location. And for this one, working with if and switch. How about this? If, switch, and flow chart activities. Remember, the description is just going to be a meaningful name that shows up underneath your actual project name inside your open recent windows. One of the most common spots that you're going to see the description, something just to give your project name a bit more of a meaningful or beefed up title is what we're going after there. So after you get this filled out and your path is set to the folder which you want to build all your projects to, simply hit create. Recall at this point UiPath is going to go through and build our environment for our project to reside in. So pulling in all the various dependencies that are part of the base or default load for project files. And here eventually we will get to a blank canvas. So recall UiPath will always open up in this main view here, asking you to open up the main workflow either here or over on your project tab. Opening up here or here yields the same results. So recall there's always going to be more than one way to accomplish the same task inside of UiPath Studio. In this case, I'm going to hit the open main workflow here, and we are ready to begin. In order to be able to demonstrate the use of selection or decision structures in here, we're going to start off by creating two new variables and pulling in a multiple assign activity in order to populate those two new variables. So bring in a multiple assign activity. Remember to bring your activities into the workflow after you find it in the list. Simply grab, click, long left hold here and drag it over to our canvas and release. And we'll bring that activity in. You heard me say we're going to create two new variables here. Recall we could come up here and do a Control and K. This is one way to create a new variable. In this case, notice a set var here. And again, I did that by holding down and Control and pressing K. This allows us to create a variable, quote, on the fly. I want to say int for integer and call this number 1 and hit enter. If I come down to variables, you'll notice that it has, in this case, predefined it as a string variable. This is the new one that it just created. I want to make these integers, so I want to make this change this to be int32. And the other way you could create new variables is to click right underneath int number 1. Notice as soon as I do that, it says variable 1. Let's change this one to be int number 2, as well as keeping this as a type of integer. Remember, go back to our data types conversation, string is going to hold text. int32 is going to hold, in this case, a whole number 1, 2, 3, 4 without any decimals. We'll get into decimal values at a later point down the road. In this case, int number 2, notice since it's already been defined, it's now showing up on my list, so I can arrow down the tab or I can double click on int number 2 at this point. To get things started, let's go ahead and assign a number. Remember, these are numbers. Do not need to be in quotes. Assign a 3 and a, let's go ahead and make it a 6 on the other side here. And you notice all the errors have gone away, but we are also at a point right now where UiPath has not been told to do anything other than these assignments. So if we run our automation right here and hit save and run, you'll notice the automation will run successfully, but we're not going to have any type of output. Nothing, what do I say? Nothing visually is appearing or happens to be occurring at this very moment in time. So we need to do some work with automation so we can actually see something happening at this moment in time. And in order for this to work, what we're all about in this case, doing our selections and decision structures. So the first activity that I want to bring in is called a if activity. And if anybody happens to be familiar with working with Microsoft Excel and playing with an if statement inside of an Excel worksheet, this is going to be a similar type of exercise in which we are going to play with a if activity, in this case inside of UiPath Studio. An if statement is all about evaluating, is a certain condition either true or false? Does the question that we are asking UiPath, does it resolve in a true or a yes answer or a false or a no type answer? Or you can even elaborate, is it on or off? You know, true, yes, or on, as opposed to false, no, or off is what we're talking about. That's where this condition box comes into play. We have to write what's known as a Boolean expression here, a statement that resolves in either a true or a false answer. And if the statement we place in this box here of condition yields a answer of true, the statement resolves to a true or a yes or a on type result, the code underneath the then side will then execute. So if this statement is true, the code on this side, the then side, will be executed, as opposed to the alternative. If it's false, off, or no, the code on the else side over here will execute. That's how a if statement works. So very similar, like I said, if you play with an if statement in Excel, there's an option there that allows you to say if a certain condition true or false. So in this case, all I did is I brought the if activity in immediately underneath the multiple assign. And by having two numbers here, I've got a condition in which I could ask UiPath, is int number 1 less than int number 2? So in order to do that, I simply come down in my condition box here and I say int number 1 is less than int number 2. You'll notice the errors have gone away. We've satisfied the important condition here of is int number 1 less than int number 2. And notice it does not require any code here. If we run our automation at this point, again, I'm going to hit save, run. It's going to be the same issue. The code is valid, but we have not told UiPath anything at this moment in time to actually display anything in our output window down here. So let's take it a step further and bring in a couple right line activities. So underneath the then and the else side, I'm simply dragging two right line activities in. What we will place in here is a statement that says int number 1 is, I'll say, less than int number 2 in a quote. Recall that's the verbal English definition of what's happening here. So int number 1 isn't less than int number 2. If it is, that's when this, that says true. It is less than int number 2. That's how we know we're going to get down on the less than side. On the alternative side would be int. If it's not less than, it must be greater than. Int number 1 is greater than int number 2. I know some of you are probably already starting to think 2 steps ahead of me at this point and are going, well, what about the equality side? And we will come down to that in just a couple of minutes. So bear with me on that thought for just a couple of moments. So it's now saying int number 1 is less than int number 2. If that's a true statement, remember it's trying to resolve true or false. That's what's going to allow us to get into the then condition down here, and that's going to tell us that int number 1 is indeed less than int number 2. On the other side, if this is a false condition, that's implying that int number 1 is greater than int number 2. That puts us on the right-hand side under the else condition, saying that int number 1 is indeed greater than int number 2. So to prove this functionality out and demonstrate it, remember we have a 3 is less than 6. So 3 is less than 6, 3 is less than 6 here. We should get the then condition here because 3 is indeed less than 6 in our statements up here. So n number 1 being 3 and n number 2 being 6. So if we run our automation here, you'll notice in the output window, we indeed got a int number 1 is less than int number 2. So again, to play around with this the other way, we can make 1 greater than 2, so 7 in this case being greater than 6. So now we know that this is a false statement. 7 is not less than 6, so that's going to put us out on the else condition saying that 1 is greater than 2. So save and run our automation here. You now see that int number 1 is indeed greater than int number 2. And as I alluded to a moment ago, what about the situation in which the two numbers are exactly the same? So 6 being equal to 6. So our question here becomes, is 6 less than 6? 6 is not less than 6, and it's not greater than 6. But our statement here is explicitly asking, is 6 less than 6? And the answer to that is false, or no, it is not. Or as I said, the off condition. So that's going to cause the code to come down here to the greater than, because this is a false statement right now. It's not true. 6 is not less than 6. It's also not greater than. It's not equal to. But notice the question is explicitly asking, is it less than? 6 is not less than 6. So that's where we get this, it's going to be greater than, which obviously is not a true statement. So we're going to have to add some additional logic to handle this situation. You'll notice the code says it's greater than, so the fact that it is not less than is an accurate assessment. So that's why we came to the else side. What we can do is bring another if statement, bring it into the else condition, and now we get into what we call a nested if situation. In this case, we have a if inside of another if. What we could do here is ask the next question, is int number 1 equal to int number 2? Are these two numbers the same? What I want to do is bring my right line activity here on this side. Obviously, if we look at our logic here, if it's 7 and 6 like we had before, recall we came on this side, and then we're asking the question, is 7 equal to 6? And if it's not, this would be a false condition. That's where we come out on the greater than side. But given our current situation, we already identified that 6 is not less than 6, so it brings us to here. That's hence our new if statement. We're saying, is 6 equal to 6? Given our logic above, that's where we need to then say the numbers are equal. So let's bring another right line activity in and simply say int number 1 is equal to int number 2. And if we save and run here, we should see our new logic come into play where it says that the numbers are equal. So there's the equal to. And the reason it's doing that again is 6 is not less than 6, called or equal to. That causes us on the right to go to the right hand side of the first if statement. And then we immediately ask another question, another if statement, is 6 equal to 6? And the answer to that obviously is true. So then we go on the then side of this nested if statement saying int number 1 is indeed equal to int number 2. To demonstrate it the other way, if we bring the number back, go ahead and stay with the 7 we had before. Save and run here. You will now see the logic in the case where it goes over to the other side to say that number 1 is indeed greater than 2. So is 7 less than 6? That's false, so we end up on the right hand side again. And then at that rate it says, is 7 equal to 6? Which we know is false. That's not true. They're not the same. That's what puts us on the else condition here, and that's where, in this case, has to be the case where int number 1 is greater than int number 2, since they're not equal in this case. Then just to play it out the other way, probably the more obvious situation now, 3 being less than 6 again. If we run our automation here, we'll immediately get down to the true side of that initial if statement, which obviously is telling us that int number 1 is less than int number 2, and that's because of this statement here. 3 is indeed less than 6, so we jump down and get into the left-hand side of the initial or the higher level if statement. One thing to point out here, notice this is not necessarily a totally true statement, but notice how difficult it is to read this, or how messy this starts becoming. Notice that a nested if statement becomes a bit more difficult or challenging to read. Especially imagine if we brought another if statement into here and had the 3-level deep nested if statement. It becomes very hard to logically read through these details. So one of the activities that I wanted to introduce at this moment in time is an activity known as a switch activity. And the switch activity has a lot of pieces to it. We're going to go through a single example of that right here. So I did a search for activities. I'm looking at switch. At this rate, I want to bring this switch activity immediately underneath our main if statement here. Notice right now it's showing an error. We got a little bit of work to do to properly configure that activity. But what I want to do here, just from a demonstration perspective, is on our main, this is on the if statement immediately below the multiple assign. I want to do a right click. This is a new thing that we have not discussed yet. And when I do this right click, I want to run down here to this item called disable activity. And what disable activity does is all the code inside of here, so in this case that if statement, when I rerun my automation, this code inside this commented out box, from when I did the disable activity, this code will not execute. One easy way to always look at this too is notice I've clicked on the comment out box. If you look real close, you'll see the blue line. If I scroll down, you see the blue box ends here. So everything from here up to that above set of where the comment out is, this code will not execute. It will immediately jump down to switch. So I didn't want to lose this. This is great for everybody to have as a reference example. In this case, I just wanted to eliminate it so it doesn't interfere us with what we're doing with our switch activity here. If you wanted to actually rerun this code again, if I come back up out to the comment outline, make sure you do this on the comment outline and do a right click and say enable activity. This will allow that code to come back and be executable again the next time I run my automation. But again, I want to disable mine, so when I go back, hit disable. So all this code in here, if statement is commented out, that code will not run the next time I run the automation. Now this new activity that we just brought in called switch. The reason I'm doing this again is to try to clean up our nested if statement here to make it a bit more user-friendly, a bit easier to read and understand the logic of our automation. Notice inside switch it has the same kind of similar case here of condition. In this case it says expression. And this expression, what's cool inside a switch, it can be evaluated in many different ways. In this case, you notice this type argument here. This is asking us what type of argument or statement do we want to evaluate as a part of this expression. So in this case, we can stay with our Boolean true, false, yes, no, on, off type situations. We can actually analyze a variable. What number does it contain in the way of integer 32? A string, what text appears in the box? And when we get into our arrays activity, we're going to pull the switch activity back in and do a little bit of a string manipulation inside a switch. So hang on to that thought. We'll have a demonstration of string inside of a switch momentarily into our next couple of activities. In this case, remember, we're simply playing with our numeric value. So I want to make sure my type argument inside of switch is set to Boolean. Again, it's evaluating a true, false. type scenario. So this is a very generic example, but again, trying to demonstrate the case of cleaning up our code from above. So our expression here, again, is simply going to be int number 1 is it less than int number 2, the same exact statement. So this expression, if you have a type Boolean set, type argument of Boolean, it needs to be just like the if statement. The statement in here needs to return back an answer of true, false, yes, no, on, off. So in this case, having it set that way is going to give us the true, false, yes, no, or on, off type answer. Inside of switch, the very first item you come to is a responsive default. This is the catch-all scenario. If for any reason this statement does not resolve any of the other cases that we're getting ready to define, that will become the catch-all bucket. So as when we get into our array activity here in a couple lessons ahead from now, we'll have a default catch-all to demonstrate the idea that if it's not in any of these other cases that we directly define, the code will immediately go into the default, and that's the code that will execute as part of the switch. In our case, we're going to make sure that we define both true and false. So notice down here, add new case. If we click on here, it's going to give us a value. In this case, since we set the type argument to Boolean, the only options available again are true and false. That statement has to come back in either one or the other state. There are no other options. When we get into any of the other values of string or numbers, we can type in freeform text into these case values. So that's where the default value becomes a bit more of a real scenario at that point. Notice inside a case true, we're saying is int number 1 less than int number 2. So similar to our left side up here. So in this case, I want to do another right line activity. I want to drag that in where it says drag activity in here for the true. This is again int number 1 is less than int number 2. That's again if I'm on case true. And I did that simply by clicking on the add new case, and I selected the option for true, part of my right line activity. On the other side of case false, this is the right hand side again. So I want to bring in, and I can combine a switch with an if. So I want to bring my if activity in here, and then recall using the same logic we had above. I want to then say int number 1 is equal to int number 2. And using our same example we had, I could have copy and pasted this, but I want to be able to walk this one through. I'm going to bring in 2 right line activities here. And obviously if they're equal, int number 1 is equal to int number 2. Then on this side, obviously, is int number 1 is greater than int number 2 on the other side. And notice in this case, adding new cases, there's really not a reason to do this since we already have our 2 up above. Since these are the only 2 options, the use of default here is not ever going to execute because we've officially answered each side of the possible results coming out of here. So if we added an activity to our default state, notice it's prompting us to add an activity, that code would never execute, again, because we've satisfied all the conditions here. The default really will come into play when we start dealing with strings and numbers as part of the answered results here. So recall back, 3 is less than 6 right now. So we're asking, is 3 less than 6? If that's a true statement, which it is, the code that executes will be on the true side saying int number 1 is less than int number 2. Recall we've commented out our if statement, so the only results we're going to see are from any of our right lines inside of our switch activity. So if I hit save and run here, playing the same example out that we had a moment ago, there's the now inside of switch saying int number 1 is less than 2. Again, that's because we're saying here 3 is less than 6, which resolves to true. We hit this right line activity here, and that's where we get our output. If we mix this up again and make it 7, Save and run. Now the code is a case where int1 is not less than int2. So going back to our switch, is 7 less than 6? It is not, it's false. It's not a true statement. So we go into our case and it then asks, is 7 equal to 6? Is it number 1 equal to number 2? And that we know is false. So that's where we are then an if, and inside of an if activity, so we go to the else condition and get the greater than response. Taking it a step further, we can set these both equal to. So save and run here. 6 equal to 6. If we save and run, we should now see that they're equal to. And again, we're in the switch activity. Is 6 less than 6? It is not, so it comes back as false. So we hit our false condition. We're now answering the if statement. Again, is 6 equal to 6? And it is true, so we hit the then condition of the if. And we say int number 1 is indeed equal to int number 2. This is yet again, the whole nature of what we wrote here is trying to help ease some of the confusion around a nested if activity like this. So notice how kind of clunky this starts looking, very confusing as to the actual flow. Kind of a bad example here because all we have is single ifs, but imagine if we had longer strands of linked activities together. We had a lot of logic inside of one side or the other section here. It becomes really difficult to see and understand where in the if statement you are when you're trying to debug the logic of your automation, as opposed to getting into a bit cleaner of an activity with switch of you're either in the true side here or you're in the false side down here. Even with this nested if at this point, notice how much cleaner this is to look at and understand the logic here, as opposed to what we're trying to look at up above here. One additional demonstration that we can discuss at this point with selection and decision structures is the use of a flowchart. And in order to demonstrate this, let's stay with our same example that we have discussed here. But from a demonstration perspective, let's go over to the project tab real quick. And we're going to create a new XAML file. This new file will not interact with our main XAML file. This is, again, is purely a demonstration and an example as to a third approach to solving, in this case, really the nested type logic that we're looking at here of, we've got multiple if statements that need to be written for the logic in which we're currently designing. So again, back on the project tab, do a right click out here in kind of this open space underneath our main.xaml file in the project.json file and say add new flowchart. I want to leave this one just this generic. Normally, as part of your typical automation, you'll want to give this file a meaningful name. What does this XAML file in this case do? What is the end result of this file? What are we trying to accomplish? In this case, flowchart is exactly what we're trying to talk about here. So we're going to leave this just as is. So go ahead and hit create. And you'll notice one little difference here compared to when we've done our sequence diagrams to this point. We now have a start state. So this idea of flowchart, the analogy I try to bring in with these is think about a Visio that you may have developed in the past. So a Visio diagram, flowchart that you may have built, or potentially inside a PowerPoint or Word if you don't have Visio available, but you've built a flowchart diagram. What's cool inside a UiPath is you can actually build what I'm going to call an executable flowchart diagram. So a diagram that is actually going to be able to execute and run as you see it depicted in a visual sense inside of a flowchart inside a UiPath. So again, we're going to use our same example, the int number 1 equal to int number 2. Notice that right now we do not have any variables defined along those lines. So I'm going to do real quickly, make sure you click on flowchart. Let's go ahead and create int number 1 again. Recall we have to do this because we're in a different XAML file. The last time we did this, we were inside of the main XAML file. These two files currently have no way to communicate with one another, and we'll have an activity and a few lessons down the road in which we'll deal with being able to communicate between multiple XAML files. In this case, we're purely doing a demonstration of flowcharts, so there's no need for these two files to communicate with one another. So again, I'm declaring int number 1 as an integer and int number 2 also as an integer again. In this case, I am going to steal our use of our default values here to make things a bit cleaner. So let's start with the case of 3 and 6 again. So 3 being less than 6, or int number 1 being less than int number 2. Remember, these default values will assign themselves to the variables at the very onset of execution of this specific XAML file. Instead of having to bring in a couple of assign activities here, the 3 and the 6 will automatically populate into each of these respective variables. So if we go back to activities, and if we type in flowchart here, you'll notice there's a couple activities that we can bring in regards to flowcharting. In this case, the first one I want to demonstrate is this flow decision. So if you bring this activity in, just like we've done before, drag and drop it in. And what we need to do is connect our start state. This is where the code begins executing. When this XAML file gets called to run, the code originates and starts here. We have to then draw, just like you would in a Visio diagram, you have to draw where do you want the execution flow to go. So in this case, start, notice as I hover over the start, you get these little gray handles that show up next to it. You click on one and start dragging down and then let go over flow decision, you'll notice it's now connected the start state to, in this case, a flow decision. The flow decision is a if statement inside of a flowchart. We have to be able to set the properties on this. And in order to do this, notice over here on the top right in the properties window, so I've clicked on flow decision, the condition is asking for a Boolean statement here. If I hover over condition, you'll see it is looking for a activity of type Boolean. Give me a true or false value back. So you have to ask a question that resolves to a true, false, or a yes and no type response. So obviously int number 1, int number 2, is it less than int number 2? Notice this is hard to read though. I've actually resolved the ask of UiPath, so I'm asking a true, false, yes, no type question here. Is int number 1 less than int number 2? But visually for us as humans, this is a bit misleading of trying to understand what this is. So what I always recommend if you're doing flow charting is to copy the condition. Notice it says flow decision here. This is also the same text that shows up here. I can either type it here or type it here, but I want to paste in our same statement here. This is purely what's in display name is the text that shows up down here. So this becomes a bit more human readable. Start, what are we checking? Is int number 1 less than int number 2? This is not the actual statement that is being analyzed by UiPath when it runs. Again, this is up here in the condition. Display name is just purely text for us humans to understand what this particular activity is attempting to accomplish. So at this rate, to demonstrate a bit more, we can bring our regular activities back in here. In this case, I want to do a right line. Notice I'm starting to run out of room. If I go down here at the very bottom, there's a little handle here that I can drag over to get a bit more real estate here. I want to drag this over, and I want to go ahead and drag my start. All this is just like Visio. You can drag things around, move things around. Notice here, as I hover over our flow decision here, I've got a true and a false kind of prompting me these little gray boxes on each side. This is where we begin to define if I have a true or false condition, what activities do I want to have executed next? So similar to how we connected start to our decision, I want to get over here and click on the true and drag it over and let it go on our right line. And you'll notice it now says true. So in our flows, if int number 1 is less than int number 2, true, yes it is. Come over and do this right line. We know this again is int number 1 is less than int number 2. So that's on a true condition. It's going to come over here and do this right line activity on this side. On the other side, we can bring another right line activity in. And we know, as kind of how we did this a moment ago, if we click on the false and drag it over, this would be the case where int number 1 is greater than int number 2. So right here and now, if we hit save, and if we hit debug file here, it's not going to execute main, it's going to execute flowchart. So if I hit play here, you'll now notice the int number 1 is less than int number 2. That's generated by this result here. Main is not being executed. In this case, it is being executed from our debug file here of flowchart. When you tell it to run from a file, it's always going to run the current file that you're currently sitting on right here. It's not going to go back to main to execute from main. The only way we would get it to do that is if we actually tell it to debug here, this would cause it to run from main. Or if we told it to actually run here, it would start from main. So in this case, running file or debugging the file will only allow execution to happen on the current file. So that's what's going on there. If we change this up, make it to where it's greater on the other side. So in this case, I'm setting the default value. So I made int number 1 greater than int number 2 to demonstrate the greater than condition. If I would debug this file again, you will see my greater than result right there. And that's going out on this side. So we have a flowchart that is actually in a executable state right now. But we also know that if we say 6 and 6, we'll run into the case where we're not going to get the equals to because we're executing our flowchart here. We haven't added the logic that we had, that nested logic from a moment ago of are they equal. So in this case, I need to delete this little false activity for just a minute. I want to bring my right line activity a bit further down here. I need another flow decision activity. I could bring a switch activity, and I want to demonstrate that before we conclude, just so we can see it. But at this rate, on a false condition, same thing, I now want to connect my conditions here. So notice the false is coming in. The check that I want to make here is going to be like we had before, is int number 1 equal to int number 2. Again, copy your condition. I want to demonstrate being able to update it here. So the text of flow decision, I'm asking is int number 1 equal to int number 2. And recall that's the condition that we specified up here inside of our box. The display name again, just so we can visually see what's going on. I'm going to drag this down just a little bit more from a visual aesthetic point of view. So obviously we need a right line activity on the left side here to say int number 1 is equal to int number 2. So at this rate, if I now connect our activities, notice I already brought my false into the ask. If they are equal, then obviously I want to go to our equal to side, so I'm clicking and dragging. If it's not equal to, then I know I'm in the case that it's greater than. So false activity there. So if I save here, you'll now notice how much cleaner this is right here compared to what we saw before. It's very easy to follow the application flow here. Start, is it true? Boom, it's immediately less than. If it's false, hey, we got another question, and then true and false on each side. So we're calling our variables 6 and 6, so we should get the equal to condition to display here. And there is equal to. We make it greater than, again, go full circle with it. Save and run with a 7, so we should get the greater than condition. And then going back to original base case. And I could make these anything, obviously less than. Just keep recycling the same numbers. We should get less than. And there you have it. That is several different ways of accomplishing the same result. Obviously being able to see kind of cleaner to a bit cleaner to maybe another alternative with flowcharts. So if statements, switch activities, and then being able to diagram through the use of flowcharts. And that concludes our activity and lesson over selection and decision structures.